If Duster can close this real to sim to real loop, essentially that means that you can suddenly train robots almost for free at a large scale. It's like singularity for robotics. So I think it's important to first explain like where real to sim comes from. Real to sim comes from the fact that there is a really good algorithm that exists that's called reinforcement learning. The problem is that this algorithm needs to do millions of trial and errors. It's not really feasible in the real world, right? You don't have an infinity of times and infinity of robots. So real to sim comes from, this very good idea. Basically assumes that you are able to recreate like high fidelity version of reality in simulation. Problem is that real to sim has several issues in practice. In the past was done by experts, in a very handcrafted manner. And this is known for a very long time. You first need to do a 3D reconstruction of the world. You need to assign, textures, basically to have photorealistic rendering of this virtual world. You also need the right physical parameters for this simulation to behave as reality would behave. And all of this actually really difficult.
Would it be fair to say that Duster is no longer just a 3D reconstruction model, but a foundational technology for connecting the real world and simulator?
Right. Yeah. The future of Duster is exactly this. So what Duster can bring to this real to sim pipeline. The first point is recreate the 3D geometry of the world. It's kind of obvious. This is what Duster is made for. You could either just take a few photos or a few videos of the environment, and that would be sufficient to recreate reality in like the finest details.
3D 지오메트리를 즉시 만들 수 있다는 것 자체가 사실은 일단은 이 리얼 투 심, 리얼에서의 굉장히 중요한 의미인 것 같다라는 생각을 한번 더 했습니다.
So what Duster is really good at, it has this prior knowledge of what the shape of object should be. This white table actually is really hard to recreate in 3D by traditional approaches because it's like a flat, like white, there's no texture. It has seen lots of tables and it has learned that the table has this, flat shape that like the normal shape of a table. Because it has this built-in like prior knowledge of the world, it can actually output clean 3D geometry, clean textures that is much easier to work with in simulation. Photorealism is another issue. Geometry is one thing, is important, but you also need typically to have photorealistic rendering of your simulation because most likely your robot has a camera and is looking around it. One thing that Duster could potentially do in the future is basically predict, not only the shape of objects, but also like the materials, the reflectance properties. These are also something you can learn at a large scale.
어떻게 머티리얼 같은 걸 학습할 수 있을지에 대해서 좀 더 듣고 싶죠.
The straightforward manner is basically just to predict for each pixel in the image. So you can imagine potentially a lot of attributes we can assign densely to all 3D points, so 3D points, in this case, you can think of them a bit like atoms. It's predicting, let's say, particles of the scenes, and each particle would be annotated. Each particle would have a set of attributes and properties. Third point is about like physical parameters of the world. Because your simulation is not just nice geometry with rendering, you want some actual physics to happen inside the simulation. And so you need to model physical properties like for instance, the mass distribution of objects. inertia, the friction coefficients, damping. The current goal is only to predict, photorealistic environments. But of course, you could imagine also predicting not just RGB colors, but you could also imagine, of course, all these physical properties and attributes. Arguably, be a simulation generator that you could use for generating as many virtual worlds as you want.
더스터는 현재는 정적인 스태틱한 이런 3D 공간을 인식하는 걸 되게 잘하지만 다이나믹한 물리적 현상을 이해하는 것은 조금 남았다고 생각하는데
There are some recent works actually that are starting to work exactly on this. This is not something we started on our side, but recent work shows that basically foundation model like Duster can be extended to predict also dynamic parts of the world. So this is actually a very hot topic right now. I think very important topics, especially for the case of like Real2Sim.
If Duster enables the condition of the real-to-sim to real loop, what kind of change could that bring to the field of robotics? What do you think?
Lots of people in the robotics community are, trying to integrate foundation models to the Real2Sim loop. Duster is not really at the point where you can readily, just push a button and you directly have some ready-to-use simulation. If we can close this Real2Sim to real loop, essentially it means we can deploy robots which are already very good from the start without any special fine-tuning, and that can accomplish the same tasks that they accomplished in the simulations, which can be any task that we want. Suddenly the rules of the game change, because you can the bottleneck that was in the middle disappears, and so everything can accelerate a lot.